For generations, our world has challenged explorers to seek what lies beyond the horizon. Now, the invention of spaceflight is leading us outward to explore a host of alien worlds with vast new territories. Today, we see the sun, moon, and planets with penetrating clarity through the eyes of the intrepid machines blazing a trail for us across the solar system. Their cameras have become our windows onto a bold new adventure. Their discoveries have become our cosmic vistas. When everything is exotic and strange, the familiar beckons. And when it comes to exploring the solar system, the familiar calls us to Mars. Although it is clearly an alien world, Mars is also a planet with landforms we immediately recognize. It is a world with deserts and dunes, cliffs and canyons, a landscape we can imagine ourselves exploring firsthand on 2 feet or on 6 wheels. But familiarity doesn't make Mars any easier to understand. After scrutinizing its landforms from orbit and sampling its soil and rocks from the surface, we have become better acquainted with Mars than any other planet in the solar system, apart from our own. But our questions about its present state and complex history have only multiplied, including the biggest question of all: did life ever exist here? Mars is not like Earth, where life is abundant and obvious. It's also not like the Moon, where there's really no chance for life at all. Mars is somewhere in between, and so it can help us define where life can and cannot exist. When we journey to Mars, we journey to the borderland. Mars' borderland status is nothing new. Astronomers have been musing about the potential for life on the red planet for more than a century. When the first grainy close-ups of Mars were radioed back in 1965, scientists were surprised and a little disappointed. The images showed a barren and cratered surface, much more like the Moon than any place on Earth. Apparently, the red planet was the dead planet, and any notion of spotting life on the surface, even primitive life, all but vaporized. But first impressions can be deceiving. As follow-up missions arrived in the late 60s and 70s with increasingly better cameras, it became clear Mars is a far more interesting and diverse planet than anyone had realized. Yes, there were impact craters, but there were also signs of a colossal geologic history. Giant volcanoes, larger than any on Earth, were found towering over the Martian plains. The largest of all, Olympus Mons, rises to a height of 24 kilometers from its base, 3 times higher than Mount Everest, making this not just the tallest peak on Mars, but the tallest in the solar system. There's a way to make an entrance my destiny. It was now a conspiracy of witches. Download V today. Such an impressive structure must have arisen through widespread eruptions of lava that poured out across the surface again and again, possibly over billions of years. Olympus Mons sits atop a giant bulge known as Tharsis that protrudes from Mars and makes it a distinctly lopsided planet. Ultimately, it led to a spectacular splitting of the planet's crust and the creation of this giant canyon, Valles Marineris. The proportions of Valles Marineris stagger the imagination. It is more than 10 times longer than Earth's Grand Canyon and 4 times as deep. Today, the best images of Mars come from the Mars Reconnaissance Orbiter, an orbiting spacecraft that carries the most powerful telescope ever sent to another world. Capable of resolving details on the surface as small as a dinner plate, it has given us an unprecedented look at Mars in all its splendor, from exquisite sand dunes to tracks left behind by Martian dust devils. But perhaps the most interesting views are the ones that suggest water once floated on Mars. Deep inside Valles Marineris, it appears as if there were layers of sediment deposited in shallow Martian lakes long before the giant canyon formed. Even the shape and orientation of the terrain suggest water once floated on Mars. These hints of a watery past grow much stronger as we cast our view beyond Valles Marineris to a series of large but empty channels leading away from the Tharsis bulge toward the low-lying regions further north. Although they dried up long ago, these valleys must have been created by vast outflows of moving water that cut across the Martian landscape, spilling out into the northern plains. In some cases, these channels measure 100 kilometers across and carve their way through thousands of kilometers of terrain. Their discovery drastically changed scientists' view of Mars. Today, Mars is far too cold and its atmosphere far too thin. Yet these channels, which bear all the marks of catastrophic flooding, suggest that Mars once had water in abundance. If so, what caused the release of this water and where did it go? The answer to the first question probably lies with the Tharsis bulge. It now seems likely the intense heat that led to the formation of Mars' giant volcanoes also forced the release of vast quantities of water stored in the Martian crust. At first, the water flowed underground, but then it broke out onto the surface, creating the features visible today. Across Mars, there are other signs that water may have flowed billions of years ago. Strong evidence from orbiting spacecraft now suggests much of this water lies frozen underground in the form of permafrost near the Martian poles. Certainly, the Martian polar regions are different from the rest of the planet. Not only do both the north and south poles of Mars have visible caps of frozen carbon dioxide that grow and shrink with the changing seasons, both possess a smaller underlying cap of water ice that is never warm enough to melt. Away, the surface at the poles also looks different. A substantial quantity of ice mixed in with the rock in these locations means cliffs and crater walls tend to slump, giving them a smooth, rounded look. One of the most exciting recent developments has been the discovery of small gullies running down the sides of craters and canyons all across Mars. They look suspiciously as though they were carved by groundwater seeping from the cliff faces and running downhill. Yet these features are so small. They must be recent. Otherwise, the steady deposit of wind-blown dust would have obscured them. Could there really be liquid water periodically bubbling to the surface on Mars? If so, the implications for life are enormous. After more than 4 decades of concentrated exploration, there's no doubt that Mars has a rich history, which certainly included liquid water and may have once included life. Furthermore, there are hints that Mars continues to be an active planet today. It is not yet a dead world, at least in the geologic sense. It is still a borderland. All of this is impetus to explore Mars further. But there are limits to what can be seen and sensed from space. To answer the question of whether Mars is a living world, we must touch, taste, and smell it. These goals can only be achieved by taking our explorations down to the very surface of Mars. We have ignition and liftoff, like the great voyages of discovery centuries ago. The journey to another world is fraught with danger. Atmospheric entry on my mark. And when it comes to landing on Mars, 5, 4, 3, 2, 1, mark. It is always the final moments. Phoenix now, 2 minutes and 25 seconds past the entry point when the peril is great. 80 meters, 50 meters, come on console. Face detected AI is 40 meters, 30 meters, 27 meters, 20 meters, 15 meters, standing by. For touchdown signal, detected. SMIT initiated. It is hard enough to design a machine that can land itself on Earth, but to do it on another planet where humans have never set foot, where knowledge of changing conditions is scarce at best, to have no margin for error between a safe landing and total catastrophe, and to do it in a place that is so distant, even a simple call for help would take several minutes to reach Earth. That is a challenge indeed, but that is precisely what must be done to touch another world. So far, 6 landers have set down safely on Martian soil, and they have transformed our understanding of the planet as only first-hand experience can. Scientifically, these missions were designed to discover the geologic history of Mars, but they also carry a powerful implication about the future. It's not just the ancient past we seek when we land our probes on Mars, but a new dawn in space exploration, a red dawn. In 1976, 2 MESA spacecraft, named Viking 1 and 2, became the first to establish a beachhead on Mars, and the view was electrifying. Geologists were immediately reminded of deserts they had visited on Earth. Once the Viking landers set to work, the similarities began to fade. While the results did not completely rule out life on Mars, they suggested that any life that managed to survive here would need to be sheltered underground or in some other impossible-to-reach location. It would be more than 20 years before another successful attempt was made to land on Mars. In 1997, NASA's Mars Pathfinder landed at the mouth of the Rovers Valley, a vast channel that looks like it was carved by running water. The landing site was surrounded by broken and tumbled rock, Boulders were slanted in a downstream direction. All signs of an was a small rover that rolled off the lander and trundled up to nearby rocks to analyze their compositions. It was a vivid demonstration of what was needed to really begin tackling the mishistory of Mars, a set of wheels. In early 2004, two rovers named Spirit and Opportunity landed safely on opposite sides of Mars, each embarked on its own motorized track. Across the red planet's surface from the start, it was obvious that the two rovers had landed in very different settings. Spirit had been sent to Gusev Crater. Evidence from orbit suggested it was an ancient lake where standing water may have left its mark in the soil chemistry. But when Spirit opened its electronic eyes, it found a barren plain littered with volcanic rock. Meanwhile, Opportunity scored an early triumph. It was sent to Meridiani Planum, where remote sensing had spotted hematite, an iron-rich mineral that on Earth is often associated with water. Meridiana turned out to be a flat, nearly featureless plain, but miraculously, Opportunity landed in a small crater with an exposed rock outcrop. For the first time, scientists would be able to sample rock on Mars in the place where it formed. What Opportunity found after wheeling up to the outcrop exceeded everyone's wildest expectations. The rock was layered and contained ample evidence that it formed in a watery environment. It also contained hematite in the form of tiny spheres, nicknamed blueberries, which grew by precipitating out of water and were later exposed as the rock weathered away. But the best was yet to come back on Gusev Crater. After investigating the terrain near the landing site, scientists sent Spirit rolling towards a set of distant hills nearly 4 kilometers away. It would take 3 months to reach the hills and many more to climb them, but eventually, Spirit reached the top and radioed back a sweeping panorama. In the years that followed, Spirit descended to the other side of the hill, surviving 3 Martian winters and eventually discovering home plate, the remains of a volcanic vent, where hot rock once made explosive contact with water. Things were also going well at Meridiani. Once Opportunity set out across the plains, it discovered an even larger rock outcrop whose layers read like a geologic history book. The story it told was of a place that once had been wet, but with highly acidic water, while at other times there was no water there at all. After nearly 2 years more of roving, Opportunity arrived at the edge of Victoria Crater and recorded one of the most spectacular vistas in the history of Mars exploration. High overhead, the newly arrived Mars Reconnaissance Orbiter was there to record the moment from space, spying tiny rover perched at the crater's rim. The journey of the Mars rovers has been a scientific adventure unlike any so far in our exploration of the Red Planet. Rather than showing us Mars in an isolated spot for a brief window of time, they have shown us Mars over many years and many kilometers, including places where water once flowed. Next, scientists wanted to know about the state of water on Mars today. Compared to the Mars rovers, the Phoenix lander was a modest mission, but with an ambitious goal: to become the first spacecraft to touch water on Mars. Scientists expected to find that water locked in a frozen state just below the surface of Mars' polar regions. Here, the landscape is dominated by low mounds with trough-like boundaries. These mounds are caused by the expansion of ground ice, forcing the soil upward. After a bit of digging with its robotic arm, Phoenix exposed something white just centimeters below the surface. It was ice, the first direct link to a watery past on Mars. Phoenix landed in the low-lying northern plain of Mars, an area that may once have been a Martian ocean. Although Phoenix could not confirm this, it found the soil here to be alkaline, similar to what might be found in seawater on Earth. What we've learned from all these missions is that Mars was a water world and still is today, although that water is hidden from view. As for what that means for life on Mars, that's a question for future missions. But in a sense, all of these missions are already paving the way for life on Mars, human life. The landers and rovers we build could be the leading edge of a new wave of exploration that might one day take astronauts to the Red Planet. If so, the human story on Mars has already dawned. For generations, our world has challenged explorers to seek what lies beyond the horizon. Now, the invention of spaceflight is leading us outward to explore a host of alien worlds with vast new territories. Today, we see the sun, moon, and planets with penetrating clarity through the eyes of the intrepid machines blazing a trail windows onto a bold new adventure. Their discoveries have become our cosmic vistas. In our solar system, gravity is destiny. It is what sets one world apart from another and puts different planets on vastly different tracks. This fundamental truth begins with the sun, a giant blazing ball of hydrogen gas, keeps shining because the force of gravity squeezes the matter in its core together until it is hot enough to generate nuclear reactions. Gravity also built the planets from the matter that swirled around the infant sun. In the beginning, most of that matter was in a gaseous state, but near the sun, it was too hot for gravity to hold on to the gas. So the planets that formed in the inner solar system were small and rocky. Farther away, it was a different story. In the outer reaches of the solar system, it was always cold enough for gas molecules to stick together and form ice. Billions of years ago, that ice gathered into bigger and bigger chunks until gravity took over, pulling in vast quantities of material and setting the stage for planet making on a giant scale. Here's what happens when you get enough gas together to make a planet. Jupiter is the colossus of our solar system. Beneath its swirling clouds, there's enough room to fit 1,000 Earths. Jupiter is big, too big to be a solid body. Instead, its interior is mostly liquid hydrogen, the lightest element in the universe. This hydrogen ocean is well hidden beneath Jupiter's turbulent clouds. Because Jupiter is liquid, it can spin on its axis at high speed, much faster than Earth. One day on this mammoth world lasts only 10½ hours. This fast spin generates high-speed winds in Jupiter's atmosphere, giving the planet a striped appearance. Somehow, Jupiter's rotation also powers the Great Red Music Spot, a giant swirling storm larger than the entire Earth that has been raging as long as astronomers have had telescopes to watch. The spot has a deep structure that penetrates many tens of kilometers, like an open window into Jupiter's atmosphere. Jupiter's visible cloud tops are made of ammonia, but scientists have not yet discovered what chemical pigment gives the Great Red Spot its distinctive color. Other storms come and go on Jupiter. This unique view made of many separate images shows the atmosphere of Jupiter as it would appear from somewhere above its south pole. Over time, the spots move and sometimes collide like giant ships on a stormy sea, but none have lasted as long as the Great Red Spot. The poles of Jupiter are also where we find intense auroras caused by solar particles trapped in Jupiter's powerful magnetic field, like giant-sized versions of the northern lights on Earth. They glow brightly in ultraviolet light. Jupiter is bigger than all of the other planets combined and more dynamic. For this reason, it is mesmerizing to watch. But there is another place in the solar system where gravity has outdone itself in creating a spectacle of stunning and otherworldly beauty. Centuries ago, astronomers were enchanted by the discovery that Saturn, the most distant planet that was known to the ancients, is encircled by what appears to be a set of narrowly divided rings. And as telescopes grew in power, so did the grace and grandeur of Saturn's rings, as these views from the Hubble Space Telescope reveal. The rings may start out at a wide angle but eventually narrow to a thin plane, almost disappearing when the planet's equator lines up with Earth. It is because of observations like this that we know the rings of Saturn cannot be as solid as they look. A solid ring would quickly become unstable and collide with the planet. Instead, the rings must be made of trillions of icy particles, ranging in size from snowflakes to giant boulders, all guided by the gravity of Saturn and its moons. In 2004, scientists were given their best chance to learn the secrets of Saturn's rings when the Cassini spacecraft made a close pass of the rings before putting itself in orbit around the planet. As Cassini raced by, scientists trained its cameras across the ring plane, capturing one snapshot after another of the detailed patterns within the rings. These wave-like ripples are caused by the gravity of Saturn's many moons, which act on the ring particles to create shifting patterns of density, while opening up gaps which are kept free of material. In some cases, these gaps are patrolled by small moons, which shift the particles with their gravity and give the rings their sharply sculpted boundaries. Here, a newly discovered moon, only 7 kilometers across, is spotted making waves in the rings on either side of a narrow gap. Cassini has also studied the elaborate pattern created by the gravity of 2 moons, Pandora and Prometheus, that shepherd the ring particles and keep them on their narrow track. Among the strangest phenomena Cassini has witnessed in Saturn's rings are these fleeting dark spokes that seem to race around the rings much faster than the ring particles themselves. They are made of fine grains of dust, probably electrically charged and swept up in the motion of Saturn's magnetic field. Saturn is alive with electromagnetic energy, and like Jupiter, its poles are ringed with bright dancing auroras. But in other respects, Saturn's polar regions look very different than Jupiter's. Here, Cassini gives us our best view, yet of a strange hexagon centered on the planet's south pole. The hexagon is made of clouds and shaped by fierce winds, but the origin of its unique geometry remains a mystery. Cassini has revealed Saturn so beautifully that it is now one of the best imaged planets in our solar system. Despite its great distance from Earth, yet with each new image, Saturn continues to surprise and amaze us. This remarkable image shows us Saturn eclipsing the Sun, a view we cannot see from Earth. It is a heavenly image, even a poetic one, made even more touching by one other tiny detail buried in the rings. Far off in the background is a small blue speck, not a faint star but a planet. It's Earth. How small we are in the solar system, but how great our reach as we send our cameras far and wide to bring us news from the lords of gravity, our solar system's largest music planets. Saturn, to the ancient astronomer, was the end of the line, the last stop before the stars. It turns out Saturn is merely the farthest planet the human eye can see. It's far, but it's not where the solar system music ends. Once the telescope was invented, we discovered there was a lot more to our solar system than meets the eye. There's Uranus, Neptune, and the weird case of a planet that's not really a planet, Pluto. But even through the most powerful telescopes, these worlds remain remote and mysterious. To probe the solar system's real outer limits, you need a spacecraft. In 1977, Voyager 2 began an epic journey that would make space history. To date, it is the only spacecraft to visit planets beyond Saturn, starting with Uranus in 1986. Uranus' most obvious feature is its striking aquamarine color. This is the result of a methane atmosphere. Methane absorbs light from the red part of the spectrum while blue light is reflected back into space. But while Uranus is unlike any planet closer to the Sun, it is not unique in the solar system. After traveling onward 3 times farther from the Sun than Saturn, Voyager 2 finally reached what is now the farthest known planet, Neptune. As with Uranus, it found a blue world, but one with an atmosphere that seemed more active, with bright white clouds made of ice crystals and dark oval music storms. Compared to Jupiter, Uranus and Neptune are small, not nearly large enough to be big balls of liquid hydrogen and helium. On the other hand, they are still far larger than Earth, too large to be solid rocky planets like our own. So Uranus and Neptune are fluid worlds, but they are mainly made of gases that freeze at low temperatures, including water, methane, and ammonia. For this reason, they are called ice giants. Although you don't see any ice when you look at these planets, they must have formed from countless icy fragments that once filled the outer reaches of the solar system. Like Saturn, both Uranus and Neptune are encircled by rings, but their rings are narrow and dark. So dark, in fact, they resemble the color of charcoal and must be rich in carbon. They may be the last remnants of small moons that were disrupted by gravity and pulverized into tiny fragments. The rings are just one element in a story that suggests this quiet and dark outer region of the solar system was once witness to scenes of great violence. Uranus, for example, is nearly tilted on its side. Instead of spinning like a top, it rolls like a bowling ball, first pointing one pole and then the other almost directly at the sun. Its rings and moons are oriented the same way, giving Uranus the appearance of a giant bullseye in space. This peculiar tilt was almost certainly the result of a giant collision long ago in the planet's history, perhaps near the time it was forming. Other signs of past collisions can be found on Uranus's bizarre icy moon Miranda, which looks like it's been blasted apart and put together again the wrong way. Its craggy cliffs are among the highest in the solar system. Meanwhile, Neptune's largest moon, Triton, orbits Neptune backwards. How this happened is not easily explained, but it is likely Triton did not begin as a moon of Neptune. As Voyager 2 discovered, Triton is only slightly smaller than an independent citizen of the outer solar system that wandered too close to Neptune and was captured. Perhaps after colliding with some of Neptune's other moons today, Triton's icy surface is crisscrossed with markings that hint at a geologically active past. The surface is made of ice, frozen water, but it's cold enough to be as hard as rock and has a strange texture resembling the skin of a cantaloupe. Much of its southern hemisphere, the only part seen by Voyager, is covered with a methane and nitrogen frost. Dark streaks on the ice are probably the residue from gas geysers breaking through the icy surface. The streaks are parallel, suggesting that winds blow fast in Triton's thin atmosphere. If Triton was captured by Neptune, then it is our first opportunity to see up close an entirely new class of objects. These are small, icy, and moon-like bodies that escaped becoming part of a larger planet when the solar system formed. Now they silently patrol the vast border region of the solar system, starting just beyond the orbit of Neptune and extending far into the deep space beyond, where the distant sun is no more than a bright star. Pluto and its moon, Charon, are surely members of the same family. When it was first discovered, Pluto was hailed as the ninth planet, but its tiny size and unusual orbit suggest it is not exactly a planet but something else. In recent years, many more objects have been spotted at a similar distance, including Eris, found in 2003. Eris is even larger than Pluto. Rather than making it the 10th planet and potentially adding many more to the list, astronomers demoted Pluto. Instead, now Pluto and Eris are grouped with similar objects in a newly created category, dwarf planet. The region where Pluto, Eris, and other dwarf planets live is known as the Kuiper Belt. As many as 70,000 separate objects larger than 100 kilometers may ultimately be found here, and they are clearly not all alike. For example, the Kuiper Belt object known as Sedna is redder than Mars. Its color may be due to chemical changes that occurred during billions of years of cosmic rays striking organic molecules trapped in its icy surface. Sedna's orbit stretches out far beyond the Kuiper Belt, suggesting other hidden members of the solar system may still be lurking just out of sight. Tiny and remote, the inhabitants of the Kuiper Belt appear as little more than dots even in the world's most powerful telescopes. Yet these objects are among the most interesting to scientists because they can tell us a story about the early days of our solar system when the giant planets were still forming out of icy building blocks like these. In 2006, to satisfy our curiosity about these most distant members of the planetary family, NASA launched New Horizons. No spacecraft has ever traveled so far to meet its primary objective, and the journey has only just begun. Now, New Horizons is well on its way to the outer limits and is scheduled to reach Pluto in 2015. When it arrives, it will be moving too fast to be captured in orbit. Instead, it will fly past both Pluto and Charon, rating back images and data and showing us for the first time what a dwarf planet is really like. At its closest, New Horizons will see details as small as 50 meters across on Pluto's icy surface and look for signs of past geologic activity. After Pluto, New Horizons will move on to other targets in the Kuiper Belt, including some which may not have even been discovered yet. If it succeeds, scientists hope the most distant and mysterious region of our solar system will finally seem a little more familiar. When New Horizons finally shows us Pluto, it will mark the end of an era. Pluto is no longer officially called a planet, but it represents the last type of solar system object that we have yet to see up close. Without Pluto, our story of the solar system and its history is missing an important chapter. New Horizons will write that chapter and for the first time give us a glimpse of the entire book. The whole solar system and all its diversity, from the blazing sun to the dark depths of the Kuiper Belt. Somewhere in that book is the story not just of rock, gas, and ice, but the story of chemical complexity and life, music itself, music. Stark desolation or breathtaking beauty, the planet Mars offers both at once and much more. No other world has so captivated human imagination, and apart from Earth, no other planet has been more closely examined or studied. Yet Mars continues to defy our expectations, and the closer we look, the more we realize we barely know Mars at all. The act of exploring another world is a plunge into the unknown, but Mars is different. So many spacecraft have been sent there that by now its major features are as familiar to scientists as the continents of the Earth. Today, the real unknowns on Mars are found at a smaller scale, a human scale, and exploring them takes on Mars than the one that belongs to MRO, the Mars Reconnaissance Orbiter. Like a great bird scanning for prey, MRO soars over Mars with its solar panels outstretched, using the most powerful camera ever sent to another world to peer down at the alien terrain passing below as it orbits. From pole to pole, MRO scans the surface, creating images in long strips that are only a few kilometers wide but could stretch to well over 100 kilometers long. Within these narrow strips, MRO's sensitive camera can perceive features as small as a dinner plate. That's many times sharper than any previous spacecraft has ever seen Mars from orbit. It means that MRO is the first orbiter with the power to connect the Mars we see from space with the Mars we wish to explore on the surface. Painted in false color, images that are chosen to bring out interesting features, MRO's views of Mars are at the level of local geography, but taken together, the small-scale details they reveal help to tell a very big story, both about the planet's current conditions and the ancient processes that produced this astonishing landscape. Because those processes involved heat and water, it is also possible that billions of years ago, they enabled the emergence of life on Mars. If life once did gain a foothold here, the evidence is buried under layers of Martian rock, layers that MRO can discern better than any other orbiting spacecraft. In fact, MRO has turned Mars into a planet of layers, allowing scientists to explore Martian history as though it were the skin of a giant onion. MRO has also shown Mars to be a planet sculpted by wind, where fine-grained dust can form vast fields of dunes that gradually migrate across the planet. The dunes of Mars are spectacular, rippled masterpieces that remind us of nature's power to create and destroy entire landscapes, one sand grain at a time. With their shifting, sinuous features, the dunes bring Mars to life, revealing the dynamic nature of its surface. But the wind can also create phenomena that are much more fleeting. In many regions of Mars, MRO has found dark streaks crossing the plains like scribble marks from a giant pen. These are the tracks left by dust devils, wispy whirlwinds that traipse across the surface like miniature tornadoes, scouring the rock clean of dust as they go. Dust devils are so common on Mars that MRO has captured several of them. Here, one twists serpent-like above the plane, casting a long shadow that reveals that dust devil is nearly a kilometer high. Elsewhere, there is a different kind of evidence that Mars can be the scene of dramatic action. Here, the spacecraft examines a crater that was not present in a 2009 photo but appeared in 2011. In false color, the freshly excavated debris of the blast looks bright blue against the dusky surface. These fresh impacts are not just curiosities. The material they expose provides clues to what lies just below the Martian surface, and sometimes they can even expose a hidden layer of ice, the frozen remains of Mars' warmer, watery past. MRO has also seen plenty of ice sitting on the surface of Mars, but this is dry ice made up of frozen carbon dioxide rather than frozen water. As it comes and goes with the seasons, the dry ice can take on a fascinating diversity of forms, sometimes appearing as though painted on the Martian surface by an artist with a flair for the improbable. Sometimes the view of a Martian polar terrain covered with dry ice can even seem to resemble bacteria under a powerful microscope. So powerful is the eagle eye of MRO that it has even been used as a telescope to look up at the two moons of Mars, Phobos and Deimos, as they orbit high overhead. These moons may someday serve as outposts where human astronauts arrive before descending to explore interesting sights on the planet below. By then, the surface of Mars will have been scouted and sampled by a new generation of robot explorers, and those robots will be looking to MRO to tell them where to land. On the smooth slopes of Pavonis Mons, a giant Martian volcano, the Mars Reconnaissance Orbiter makes a startling discovery. A small crater alone on the featureless landscape appears to have a strangely dark center. Looking more closely, MRO finds that what seems like a crater is really a natural skylight where part of a volcanic formation has collapsed, exposing a hidden cave below. This remarkable picture invites the tantalizing prospect of someday entering the cave and exploring Mars beneath the surface. However, falling into such a hole unexpectedly would spell disaster for a rover on Mars, and that's why orbiting missions are used to spot both the hazards and identifying potential landing sites on Mars, providing unprecedented details and aiding in selecting landing spots for subsequent missions. Despite the presence of the Spirit and Opportunity rovers on Mars prior to MRO's arrival, the orbit's powerful vision allowed it to spot these rovers on the surface. The orbiter also assisted in pinpointing potential landing sites for subsequent missions. When the Phoenix lander was being planned to explore the north polar regions of Mars, MRO's improved view led to the discovery that the initially favored landing site, Region B, was unsuitable due to boulder-laden terrain. As a result, a backup landing site was chosen, where Phoenix safely landed in May 2008. Additionally, MRO aided in selecting landing sites for the next mission, targeted to deploy a sophisticated mobile laboratory rover which aimed to determine if Mars had once harbored conditions conducive to life. MRO meticulously analyzed over 60 candidate landing sites, subsequently shortlisting 4 finalist locations by 2011. These included intriguing and geologically complex spots such as Holden Crater and Everald Crater, each exhibiting compelling evidence of past flooding and ancient geological formations. Landing site presents itself at Marvalis billions of years ago. This channel drained a torrent of water from the Martian highlands in the south to the low-lying northern plains. All 3 of these sites show terrific potential for uncovering the history of water on Mars. But in the end, scientists chose a 4th site, a site that combines some of the most attractive features of all the others in one location. It adds a mysterious mountain that could unlock the secrets of ancient Mars. After more than 40 years of interplanetary exploration, Mars has offered some of the most spectacular sights in the solar system. From huge volcanoes to deep chasms to the beautifully sculpted layers of ice and dust that cover the Martian poles. But among its many diverse and intriguing features, there is nothing on Mars that looks quite like this. A giant mound more than half the height of Mount Everest, sitting squarely in the middle of an ancient impact crater. This is Gale Crater, a formation that has long attracted interest and speculation from Mars scientists. It's also the landing site of the most ambitious mission ever to touch down on the Red Planet, NASA's Mars Science Laboratory, better known as the Curiosity rover. Compared to previous rovers, Curiosity is built like a tank, the size of a small car. It weighs 900 kilos and carries 10 separate scientific instruments for the detailed testing of the rocks, soil, and atmosphere of Mars. But most importantly, Curiosity is powered by a device that generates electricity from the radioactive decay of plutonium. Curiosity's nuclear power supply would give it the potential to explore Mars for years, allowing scientists to select a more ambitious target. Few features on Mars are as scientifically interesting as the mountain in Gale Crater, nicknamed Mount Sharp after a pioneering planetary scientist. This strange formation rises above everything else around it, including the rim of Gale Crater. Closer inspection by the Mars Reconnaissance Orbiter has revealed that the mountain is really a pancake stack of sediment, whose lowest sections are made of clay layers that formed in the presence of water. Those layers could well be a gold mine for scientists because they represent a slice of geologic time that spans over 100 million years of the most crucial period in Martian history, a time when Mars may have shifted from a habitable planet to a frozen desert. They're in one piece after years of planning and an 8-month journey from Earth. The moment of truth arrived on the night of August 5, 2012. Nested safely in its protective capsule, Curiosity jettisoned its cruise stage and, drawn by the planet's gravity, began its terrifying plunge. Soon, friction with the thin Martian atmosphere began heating up the front of the capsule to a peak temperature of over 2,000 degrees C. Now, still traveling at over 1,400 kmph and just 11 kilometers from the surface, Curiosity deployed its parachute. 15 seconds later, the heat shield fell away, revealing the rover tucked inside. But now the rover was still falling fast. When it separated from its parachute and back shell and ignited 4 powerful descent rockets, but how exactly to land? Separating from its descent stage, the rover was lowered to the surface on 3 nylon cables. As it touched down, the cables were cut, and the descent stage veered off, crashing to the surface a safe distance away. And then came the signal. Curiosity is the seventh mission to land successfully on Mars, but it's different from all its missions to combine the mobility of a rover and the scale and complexity of a field laboratory with the potential for operating for years on the planet's surface. That combination will change our understanding of Mars forever. This will be the longest journey ever attempted on another world, but it will not be as lonely. As Curiosity begins its epic trek across the surface, it will be watched from above by NRO, the evil eye that has become part of day-to-day life on Mars. Even as we look for signs of life in the past, at a distance of 150 million kilometers from Earth, the Sun is all the star we need. Its energy, channeled by our atmosphere, keeps our oceans liquid and makes life possible. But imagine if the Sun were more than 3 times larger in our sky and blasting every exposed surface with up to 10 times as much energy. Then Earth would be a very different world, a world ruled by heat and light, a world like Mercury with its baked and battered surface. Mercury seems like a no-man's land among the planets, but it's a no-man's land that scientists need to explore. As the nearest planet to the Sun, Mercury lives in a cosmic hot zone that holds important clues to the origins of our solar system. It may be our key to understanding conditions on countless alien worlds scattered throughout the galaxy. For centuries, Mercury eluded astronomers' best efforts to learn its secrets. The reason comes down to geometry. As seen from Earth, the angle between Mercury and the Sun is never more than about 30 degrees. The only way to separate the planet from the Sun's overpowering glare is to look very low toward the horizon immediately after sunset or just before sunrise. Under such conditions, even the largest optical telescopes in the world were not able to show any detail on Mercury's surface right up until the dawn of the space age. All of that changed with Mariner 10, launched in 1973. This intrepid spacecraft was designed to fly by Venus, but scientists realized they could get 2 planets for the price of 1 by including Mercury as a second target. During 1974 and 1975, Mariner 10 made 3 separate passes of Mercury, coming to within 3,327 kilometers of the planet's surface during its third and final approach. During those historic encounters, centuries of speculation were replaced with a stark new picture of the solar system's innermost world. Mariner 10 revealed a heavily cratered planet that looked a lot like Earth's moon. Most of the craters date back billions of years, because Mercury is too small and too hot to hold on to a thick atmosphere. Its surface does not experience erosion from water or wind. Yet, hidden in this ancient surface are tantalizing signs that Mercury has changed over the eons and that, despite its outward appearance, Mercury is very different from our moon on the inside. One clue is the planet's surprisingly large mass. Mariner 10 found that Mercury is nearly 5 times more massive than the Moon, even though its diameter is only 40% greater. To be so heavy, Mercury must conceal a huge metallic core covered by a relatively thin skin of lighter rock. This idea was further reinforced by Mariner 10's discovery that Mercury has a magnetic field, although it is much weaker than Earth's. The presence of the field suggests that at least part of Mercury's core is still in a molten state. Mariner 10 tried to glean further clues from its reconnaissance of Mercury, but during its 3 brief passes, the spacecraft imaged less than half of the planet's surface, and what it found left many unanswered questions. Clearly, another mission to Mercury was needed, one designed for a much longer stay. But even though Mercury beckoned, the dream of returning would remain unfulfilled for nearly 30 years. At last, on August 3, 2004, NASA's MESSENGER spacecraft set out to become the first planetary probe to orbit Mercury and reveal its features and characteristics in detail. But just getting there would be half the challenge. Mercury is much closer in our solar system, orbits deep within the Sun's gravitational field at a significantly faster speed of about 65,000 kilometers per hour compared to Earth. NASA's MESSENGER spacecraft undertook a challenging 6.5-year journey to orbit Mercury. During 3 near passes, MESSENGER tested its cameras and sensors, providing spectacular but fleeting glimpses that amplified scientists' appetite for more data. In March 2011, Messenger approached Mercury for the fourth and final time, being captured by the planet's gravitational pull. This marked the beginning of the long-awaited exploration of the solar system's innermost planet. Equipped to endure the intense solar radiation, Messenger utilized thermal insulation, a system of radiators, mirrored solar panels, and a sunshade to regulate temperature and protect its sensitive electronics. Despite the hostile environment, Messenger's cameras allowed for detailed mapping of the planet's surface and revealed subtle color differences in its rocky terrain. Messenger's findings also unveiled the unique characteristics of Mercury's craters, demonstrating differences in color between craters such as Dega and Bront. While the tradition for naming craters on the Moon typically aligns with scientists and philosophers, Mercury's craters are named after artists, composers, and authors. The spacecraft's comprehensive imaging capabilities provided insights into the multi-layered history exposed by Mercury's craters. This difference suggests that Mercury's surface includes layers of rock with different compositions. In this case, the impact has punched through a bluer-colored rock underlying the brown. Elsewhere, the color differences are more complex, pointing to a rich and diverse geologic history that was not apparent to scientists before Messenger arrived. Sometimes, the effect of an asteroid or comet strike is obvious because it scatters material in bright rays across an older set of features. But not every part of Mercury's surface is shaped by an impact from above. In this intriguing image, a smudge of orange stands out against a darker colored landscape. Seen up close in black and white, the object at the center of the smudge looks like a tall peak inside a crater, but this is no ordinary crater. It's the likely scene of a volcanic eruption that sprayed out orange-colored material from deep within the planet's interior. Messenger has confirmed that Mercury is covered with features like this one that could only have resulted from volcanic activity. Here, a crater named Faller looks half sunken into the landscape. The crater was probably flooded by lava, which topped its ancient rim and half filled it with molten rock. Elsewhere, the large crater Rachmaninoff features a double rim, with the outer ring measuring more than 30 kilometers across. Color differences show that lava flooded the center of the crater long after it formed and then spilled over into the region between the inner and outer ring. In other cases, the colors on Mercury's surface are harder to interpret. For example, some crater floors have bright hollows, which stand out against the darker rock and are completely unlike anything seen on the Moon. The exact nature of these bright patches remains a mystery, but scientists suspect they may be the result of some minerals becoming gaseous under the sun's intense glare. One area where Mercury's color is especially revealing is the Caloris Basin. At 500 kilometers across, it is by far the largest impact feature on the planet. Caloris formed in the first billion years of the solar system's history when a very large asteroid struck Mercury. Over time, other smaller craters scarred the basin. Then, lava covered the basin's vast central plain, leaving the raised rims of the smaller craters to stand out like blue islands. In contrast, the edge of the giant basin is marked with orange spots, where hot lava found a path to the surface through the shattered bedrock. Meanwhile, at the center of the Caloris Basin, Messenger has discovered a strange network of troughs that spread spider-like across the basin floor. These are indications that the surface of the basin may have been pulled or stretched in the past. With its oversized metallic core, there seems little doubt Mercury's pockmarked surface. Hundreds of light years from Earth, a newly discovered world basks in the fierce light of an alien sun. This is one of scores of planets uncovered by NASA's Kepler mission, which was designed to hunt for worlds like Earth, small, rocky, and at just the right distance from their stars to allow for the presence of liquid water. But in the course of its search, Kepler has also found many planets that are more like Mercury, orbiting much closer to their stars. Long neglected by planetary explorers, Mercury has now become our best reference point for understanding countless other hot worlds that populate our galaxy in the billions. Of special interest to scientists are those features on Mercury that are found nowhere else in the solar system. Features like towering cliffs that snake across Mercury's battered terrain for hundreds of kilometers. Here, one such cliff slices the ancient crater Ramo in half, leaving one side of the crater 2 full kilometers higher than the other. Having imaged the entire surface of Mercury, NASA's Messenger spacecraft has confirmed that cliffs like these are widespread around the planet. It's now believed that they formed when Mercury's giant metallic core cooled and gradually shrank. This left the planet with an outer skin that was too large. As the interior grew smaller, the surface buckled, forming cliffs like giant wrinkles in a planet-wide shrink wrap. The cliffs are an example of how Mercury's outer appearance has been shaped by internal forces. As scientists combine Messenger data with ground-based radar measurements, the true nature of Mercury's dynamic interior is now coming into focus. A key discovery is that Mercury's metallic core is even larger than expected, accounting for 85% of the planet's total diameter. But while the inner portion of the core is likely made of solid iron like Earth's, at least some portion of the outer core must be liquid. It is the motions within this electrically charged liquid that are responsible for generating Mercury's magnetic field. However, this picture presents scientists with a dilemma. If Mercury's core is made only of iron, it should have completely solidified by now, since the smaller the planet, the more quickly internal heat escapes. Even for a planet as hot as Mercury, this has led researchers to speculate that lighter elements like silicon and sulfur are present in Mercury's core in significant amounts, which would lower the core's melting point and leave the outer portion liquid. Mercury's liquid core may even be surrounded by a shell of solid iron sulfide, something not seen on any other planet. But while this explanation satisfies all the data, it leads to a larger mystery. In order to explain why Mercury's core is so large, scientists have speculated that Mercury was once more like Earth or Venus, a larger planet with a thick rocky mantle surrounding its core. Then an enormous collision with another object blasted off much of that mantle, leaving the core intact. Another theory suggests that in the very early days of the solar system, the Sun went. Mercury, though small and close to the Sun, presents mysteries that challenge current understanding of planet formation. Messenger's findings suggest that the planet may have formed small but rich in lighter elements, defying traditional theories. Surprisingly, Messenger also detected ice on Mercury, previously hinted at by radar observations. This ice is located in perpetually dark craters at Mercury's poles, acting as cold traps for water vapor brought by comets. Messenger's neutron spectrometer suggests there could be up to 1 trillion tons of ice on Mercury, making it a tempting target for future explorations. This unexpected discovery makes Mercury not just a hotter version of our moon, but a unique world, crucial to our understanding of rocky planets. The European and Japanese space agencies are planning a mission to Mercury in the next decade to further unravel its mysteries and shed light on the emerging population of newfound worlds. On another celestial body, Mars, NASA's Curiosity rover has landed, beginning a mission to explore the red planet's past habitability. The advanced rover aims to revolutionize our understanding of Mars, following the significant achievements of its predecessors. Rover, a groundbreaking exploration mission on Mars, was designed with the capability to determine if Mars could have supported life in the past. Weighing 900 kilograms, it carries 15 times more scientific instruments than its predecessors, enabling it to act as a mobile laboratory. Equipped with a laser for analyzing rock composition, a 2-meter-long robot arm with a camera and spectrometer, and a drill for collecting rock samples, it's a remarkable planetary explorer set to unravel Mars mysteries. Choosing the Gale crater as its landing site, scientists believe it might offer signs of a habitable past. The crater features a 5.1/2 kilometers high mountain, Mount Sharp, rising from its center. Ulus Mons, as it's officially known, might hold millions of years of geologic history within its layers. The lowest layers suggest water deposition, while the upper layers indicate dry, dusty conditions, presenting a complete story of Mars' evolution. Upon landing, Curiosity set out to explore its immediate surroundings before embarking on its journey to Mount Sharp, a trip that would take over a year. This mission aimed to study Mars' potential habitability in its past and represents a significant leap in Mars exploration. The Curiosity rover set out to explore Mount Sharp to study its layered geology, which hinted at Mars' complex history. However, Before heading in that direction, it explored its immediate surroundings, revealing compelling findings. It discovered conglomerate rock and rounded pebbles, suggesting ancient stream beds, raising questions about the potential for past habitability on Mars. Additionally, it sought to investigate the presence of methane in the Martian atmosphere, a potential indicator of biological activity. Initial reports indicated the presence of methane, but Curiosity's direct measurements found no significant amounts, presenting contradictory evidence. With the methane question temporarily resolved, Curiosity continued with its exploration of Mars, leading to the exceptional discovery at Yellowknife Bay. The rover's advanced imaging captured an incredibly detailed panorama, marking a significant milestone in its mission. Further analysis of the geological features at Yellowknife Bay revealed sedimentary rock layers suggestive of past water flow and even signs of an ancient lake. Curiosity's examination of mudstone layers and mineral veins indicated prolonged exposure to water, providing valuable insights into Mars history. This discovery prompted the rover to drill into a rock called John Clean, gathering powdered samples for onboard analysis, representing a pivotal moment in the mission's scientific pursuits. Surface. The powder was gray rather than red in color. That meant the minerals inside the rock had been sealed off from the atmosphere for billions of years. Here was a rock that offered a direct connection to the past. In March 2013, 7 months after Curiosity arrived on Mars, scientists were ready to share their results. A detailed analysis showed that the minerals in the rock had formed in water that was much like fresh water on Earth, non-acidic and not very salty. Furthermore, there were chemicals in the rock that the right kind of microbes can use to drive metabolism. Curiosity had found the key ingredients that could have allowed life to flourish when there was water in Gale Crater. For Curiosity, this was mission accomplished. While it's still not known if Mars ever harbored life, scientists can now say life was at least possible there billions of years ago. With the discovery came the news that the rover's mission had changed. Having answered its original question, Curiosity would now try to find out where and how to search for signs of past life on Mars. By the summer of 2013, the mission reached a major turning point. After making several more follow-up measurements, scientists said goodbye to Yellowknife Bay forever and put the rover on course for Mount Sharp. The first phase of the mission was over, and there were new discoveries ahead. But before it left, Curiosity provided its own glimpse of life on Mars by using its robotic arm to take this striking self-portrait at John Klein Rock. It may be a long time yet before we know if there ever really was life on Mars, but we know that Curiosity is there, and that's a terrific start.